All right, so up until now we've been solving systems of equations. We started this chapter with graphing, elimination, substitution. That was for equations because we were looking for where the two lines did what? Intersected or had the same values, right? And so now, then we did matrices, but we had to learn all about the way matrices work first, and then we solved systems using matrices. But those were, once again, of equations. Systems of inequalities, as you see here, the best way to do it is graphing because of how many answers there are. There's way too many to try and narrow it down to just one because there isn't going to be just one. Okay? And so what you normally do is you will see something like this, and this is a system. You see that there are two unknowns and two inequalities. So we have enough information to be able to try and solve this one. When I do these, what I like to do is try and get the boundary lines, is what I call them, first. So just pretend it's equals first, right? And then this one over here, if I wrote it over here, right, is equals. And when you have inequalities, they don't have to be lines, but that's what we're going to deal with in here. They could be parabolas and other things. But for us, we're just going to deal with some system of equations that are more linear. And so this one here, we're very lucky that it happens to be in slope-intercept form, right? And so this slope right up here is 1, and the y-intercept is 5, right? And so graphing that one's not too hard. And if you are really not good at graphing it that way, is there anything wrong with going with the old standby of an XY table? Is there anything wrong with doing that if you get confused with the other way? No. Just get that boundary line on there somewhere. So do you agree that if the y-intercept's 5, it should be up there, right? And I'm going more with the slope-intercept form. If the slope is 1, that means the change in y over the change in x has to be 1. How many ways can you write 1? How many different ways can you write 1? Infinite ways, but you just got to choose whichever way you want to. So we maybe would write it 1 over 1 or maybe 2 over 2 or whatever. So my change in y is 1, change in x is 1, so up 1 over 1. Do you agree with that? Right? And so our line is going to look something like that. And I believe I already have it in there, so I'll just tap the screen and hopefully I get something. There it is. Okay. I got the dot because the y-intercept was 5, right? And so I went on the y-axis up to 5. Or you could have done an xy table and just got a bunch of points, right? And how come, that seems rather strange. Did I make a mistake there? My line is dashed. Why is my line dashed? Yes? Okay, very true. What was said is that if we had the equal to on there, then it would be solid. Now, does anybody know the real reason? Now, that's like a helpful hint, right, as to know if the equal to is on there, you make it that way. If the equal to is on there, it would work because the points on this line would actually, the combinations of x and y would actually make the inequality true. If it's not on there, do the points on this line, the ordered pairs x and y, do they make the inequality true? They don't, which is why we make them dashed. But that's also why I call these boundary lines. They might be part of the answer, they might not be. So right now they're not. So basically right now, how many solutions do I have graphed to that first inequality? I don't have any graphed. That's just a boundary line. Where are the solutions? I don't know. And so normally what you do is the solutions will either be above your boundary line or below it. So we have to just test a point and see what happens. And whenever possible, you use the easiest test point there is, 0, 0, right? Let's try 0, 0. Now you can try 0, 0 because it's not on the line, right? It's not on my boundary line, so I can try it. So you put 0, 0 back into the inequality, and you see if it's true. So does the ordered pair 0, 0 make our inequality true? And so you put 0 is greater than 5, right? That's what you get. Is that true? That's not. So in other words, you're telling me that point right there does not make that first inequality true. So what do you think about all the rest of the points that are down here? Are any of these going to make it work then? No, none of those are going to make it work. So where are the answers that are going to make it work? Above it, right? So they're up here. And what that means is I can take any combination of x, y that happens to be up here, and it'll make that inequality true. Any one I want. Okay? And would anybody like colored pencils? I can grab them if you don't want to shade with them. No? Okay. So now let's go ahead and take a look at our other boundary line. So y equals mx plus b, right? You agree it's also in that form? Would you prefer to see this one xy table? Okay, sure, no problem. I just saw some of you looking at the slope-intercept like, I don't know about that, right? So let's do it the other way. If you're not sure, let's find the other way. So what's always a nice, easy value to kind of substitute in? 0, 1, any of those, right? So let's put 0 in. What that means is put 0 in that location, right? Right there. So if I put 0 there, what y value results? -2, right? Now if I just have 1 point, that doesn't quite give me a line, does it? We should probably do at least 2 and maybe even 3 just to make sure, right? And probably the next easiest is 1, right? So we put 1 right in that location there, and the y value that results is, careful, put 1 in, I get -1. It's very easy to mess that one up though. And a very good choice then for x. Somebody see a really good choice? Based on the numbers there is 2, right? 2 is a really good choice, right? Because if I put 2 right in there, I get 0, right? Okay, so we got a bunch of, wow, that's the worst 0 ever. All right, there we go, 0, that's better. All right, so 0, -2, and 1, -1, and 2, 0, right? Wow, that's, yeah, that's right. Now, of these 3 ordered pairs, if I put them back into the original inequality, which is up here, do you think any of those 3 would make the inequality true? No, they don't make it true, do they? So it's a boundary line, but doesn't actually contain answers, right? And so what do we do with those boundary lines that don't actually contain answers? We make them dashed, okay? To show whoever's going to look at my graph that those actually are not answers. Okay? So now once again then, for that second inequality, I don't have any answers graphed yet for the second one. And so am I allowed to choose 0, 0 again then? Can you do that? Yeah, because it's not on the boundary line. So yeah, go right ahead. Try 0, 0. We'll do it in blue this time so we can kind of color code things. I got so many lines and arrows up here, it's getting confusing. All right, so we put 0 in for y, 0 in for x, and we basically get that 0 is less than -2. Is that true? Is 0 less than -2? No. And so in other words, these points up here aren't going to work, right? But which line was I referencing? I was referencing that line, right? And so I'm going to shade the other way then. Uh-oh. There we go. It's back. Okay. Any questions on how we shaded? Exactly. Great question. The question was, if it is true, you shade that way, and that's exactly correct, because that's showing you that those answers are that way, right? Now, when we did systems, you already said it, when we did systems of equations, we wanted to find where the 2 lines hit each other, right? So what do you suppose we're looking for when we do a system of inequalities is, yes? No? I think you're on the right track. So basically, I want to find points that make both inequalities true. So wait a minute. If for the first one, all the answers are up here, in the second one, all the answers are up here, are there any answers that work in both inequalities? No, there's not, because you're looking for where they shade together. So you see how that's very similar to a system of equations. Where are they together? So wait a minute then. So which points work in both inequalities? No points do. So what's the solution to this system of inequalities? There is no solution. And we write that as what's called, to show your solutions, you write it's the empty set. That's what that stands for. That means my set of answers is nothing. It's the empty set. Okay. Now, that does happen from time to time, but not very often, because you realize your boundary lines have to be parallel in that case, right? And they have to be shading away. Okay. Any questions so far? Okay. On this one, we're going to first solve the system by graphing, and then it does have us doing something else. But let's just worry about the graphing part first, and then we'll come back to that other one. So what was my first step back here? What was the first thing I did? Yeah. Perfect. I took each inequality and made them equals instead. So I could find out where the boundary line was, right? So this one here, we would just make x equals 0. Now please remember, x equals 0 is a line, right? It's a line where all the x values are 0. So if you wanted to make, and the easiest way to remember that is you just make yourself an xy table, and you just make x 0 every time, right? And then you just go 1, 2, 3, whatever, right? So 0, 1 is here, right? 0, 2 is there, 0, 3 is there. Are you starting to get the idea where this line is going to be? Right? Kind of vertical. Remember, x equals a number is that vertical case. And what's the slope on that one again? A vertical line, the slope is undefined. Very good. And should this line be solid or should it be dashed? In other words, 0, 1, 0, 2, 0, 3, do they make that inequality true? Yeah, they do because of the equal to on it. They do. Because if I put 0, it's 0 equals 0. Hey, it works. So this boundary actually does work, and so it should be solid. Because those actually make it true. Because the y value has nothing to do with that inequality. Okay. Now this one, we'll go down here, turn it into y equals 0. You notice I'm not looking at the shading quite yet, and I'll show you why in a second. Okay. And then I'll give you maybe a suggestion that I've seen some people do in the past. So y equals 0, again, it's very similar. It's another one of those specials, right? And you could do an xy table again if you wanted to. But basically, you have to find all the places that y equals 0, and that happens to be that one, right? Because any point on that line right there, the y value will be 0. What some people do in these is they get all the lines on there first, and then they worry about shading. And if you think you can do that, go right ahead. It's fine. But right now, if you think about it, x being greater than 0, that means x has to be positive, right? Greater than or equal to 0, positive or 0. Y being greater than or equal to 0, same thing. Y has to be 0 or positive. So far, we've pretty much restricted ourselves to the first quadrant, right? Because that's where x and y are both positive. You with me on that? Okay. Because that's sometimes how I look at those things, just like that. And that's why I did both of them right away, because those are, I knew they were horizontal, vertical. They were going to contain a spot. So now x plus y equals 5. We've got to do that one yet. This is definitely different from the front, because it's still going to be a line. Because it's x to the first, y to the first. They're not multiplied or anything, so yes, it will be. But it is not in slope-intercept form, is it? What form is this? Anybody remember? Standard form. Very good. And I think standard form is very easily done with an xy table. Okay? And what I normally do is find the x-intercept and y-intercept. Or what I like to do, it's not really cheating, it's planning ahead. When I see these kind of things earlier, I make x and y equal those things in my other tables, because it's probably going to be helpful. So let's make x equals 0, because that's what I have here, right? And let's make y equals 0. It's a different order pair, though, okay? You see that? So if x equals 0, then what would y have to equal in this one? 5, right? And if y equals 0, what would x have to be? If y is 0, x would have to be 5 to make it true, right? And so we know we got 0, 5. And 5, 0. Just like that. Now, of course, you could get another point or two if you want to be sure. Okay? But I'm fairly confident in my points. And 0, 5, 5, 0, do they make this inequality true? They do, because of the equals, right? They actually do make it true. So this line will, once again, just like the other ones, be solid. Okay? How are we doing so far? Everybody hanging in there? All right. So for us to shade together, either I'm going to shade above that line, right? I'm either going to shade above, which would mean kind of here's where our answer is, right? Or I'm going to shade below that line, and then they would overlap right in there, correct? One of the two is going to happen. We have to figure out which one. There is no guarantee which way this is going to go, and so we got to try a test point. If this is the line I'm trying to reference, is it okay to use 0, 0 as a test point? Yeah, because it's not on the line. 0, 0 is fine. And so let's stick with that easiest one to use. Have you noticed that I have not been substituting back into the equals? When I test a point, I always go back to the inequality. Have you been noticing that? Okay. So let's get rid of some of this stuff here. And let's go back to the inequality. So 0, 0 is the point I'm going to test. So 0 and 0, because that's what I got to put in there, less than or equal to 5. Is that true? It is. 0 is less than 5, right? So in other words, I would shade that way, which kind of goes to that question from earlier. If it does work in that direction, you shade it that way, right? Now remember, if it's a system of inequalities, you want to know where they shade together. Where do they overlap? Okay, and somebody kind of was chasing the triangle with their pen, and that's exactly where it goes. It shades in here. Agreed? So all of these are answers. And not only are all of those answers, all of these points in here, all over the place, even on those lines because they're solid, will make all three of those inequalities true. Not just one of them, not two of them. Every single point in there will make them all true. And how many points are in there? Infinite. Okay, so could you imagine if you tried to rate them all? Yeah, you really can't. There's some notation you can use, but it's probably easier just to show somebody where they are. Okay? So far, we have solved the system by graphing. Now it says, then name the coordinates of the vertices of the polygonal convex set. Basically what it's saying is hopefully, or possibly when you do this, you make a convex polygon. Remember, convex versus concave? Concave means the polygon caves in. Did I make a convex polygon with my picture? Yeah, it's the triangle, right? It's a convex polygon. It's right there. So I would like, say, convex polygon, so please give me the vertices of it. So the vertices, there's one. There's one. There's one. Well, this one's probably the easiest one to write. It's 0, 0, right? How about this one way up here? Is 0, 1, 2, 3, 0, 5? And this last one is 5, 0. So now do you see why I had ideas to do something like that? Because more than likely, at least one of those points was going to be important. And because I saw these earlier. So I knew more than likely it was going to be helpful. Okay, so that time they did actually overlap somewhere. And there's a lot of answers to that system. Okay. What I would like to do right now, I'm going to pause it and have you try this one. If you happen to be listening to the recording, actually please pause it for a second or two and actually try them and then start the recording back up. Okay. All right, we're back. And as I went around, I've noticed in years past, and even this year, that some people kind of just get the lines in there and then decide where to shade. And that actually is a pretty good strategy because, as someone said, there's just so many lines in here. I don't know where to go. And that's a very good point. And that's why sometimes colored pencils can be helpful. So remember, the first thing you do is look for those boundaries. So this is x equals 0, y equals 0, right? Those should be fairly similar to the ones we just had. Right there, and they are solid again because those points on those lines actually make those inequalities true. These next ones, it all depends on how you want to do it. But again, if I'm going to do an XY table for this one, I'm probably going to look back over here and say what values are probably going to be helpful. And I would say, well, x being 0 and y being 0 are helpful. And so if I make x 0 right there, what does y have to be? Again, if you're making it equals. It has to be 4. And if you make y 0, x has to be 2. So basically you got, what, 2, 0 here and 0, 1, 2, 3, 4. Now there's no guarantee that both of those points are going to be helpful, but I'm pretty sure at least one of them will be, right? Because we have 4 inequalities and 2 unknowns, so we got plenty, right? And so if we got that line right there, there it is, right? And it's solid, okay? And so now we do have one more, so we might want to take a look at that. And again, you can do it however you feel like it, but it looks like XY table's been a pretty common way of going about it. And again, you look back over here, and 0, 0 seems like good choices. And if you put 0 in for x, we better have, again, we're pretending equals. Better have 3 and then 3, 0, right? So we got that one there, and then we got that one. So it looks like this one's kind of slicing through the other one, right? Something like that. And then the point was brought up, okay, I know with these first two that x greater than 0, y greater than 0 means I'm kind of, again, shading in the first quadrant, right? So I'm basically shading all of this. But then the question is, am I supposed to shade those little guys? Am I supposed to shade this? Am I supposed to shade over here? I don't know. Because is there any guarantee that you make a polygon out of this? There's no guarantee, all right? And so you have to kind of say, all right, well, let's try and find out. And so far, we know we at least have that much. But basically everything except for quadrants 2, 3, and 4 have been shaded at this point. And so what you do then is you go back here and you test some points. So that one right there is dealing with, so this one here is dealing with that line, correct? And so either I'm going to shade below it or above it. One of the two is going to happen. And so can I use 0, 0 as a test point? I can, right? It's sitting right here. I can test it. 0, 2 times 0 is 0, right? Plus 0 is, well, 0, right? Less than or equal to 4. So is 0 plus 0, which is 0, less than or equal to 4? It is. So from this line, I have to shade this way, correct? So the only thing I've eliminated is that little area, basically, right? Is about all I eliminated with that. Okay. So now I'm going to have to go to the other one. And what color do I got left here? Black, I guess. And so what we have to do is check that other one. And so if we're going to deal, this one deals with that line. And 0, 0 can be tested again. 0 plus 0 less than or equal to 3. It is. So that one works. And so then I have to shade. So that eliminates that little guy, right? Where do they all shade together? It's not quite it almost looks very similar to the triangle we had last time, right? Except now there's a little kink in it. And so I know you can't do this on your paper, but that's what I'm going to do. You go here, to there, to there, to there, to there. Once again, what that means is every point in here, anyone you choose, even on those lines, right, will make all 4 of these inequalities true. Not just 1, not just 2 or 3, all 4. Okay? And really, this is where one would even want to consider doing a system of inequalities, is this next step. Have we now found the polygon? There is a polygon. There's no guarantee I was going to get a polygon, but we do have vertices, right? 3 of which we know for sure, and this one here, well, we're not quite sure, but our graph's pretty good, so we might be able to get it, right? So we know for sure that that one, the very first one here, is 0, 0. And by virtue of how we made this, we know that one is 0, 3. Again, by virtue of how I made it, I know that one is 2, 0, right? It's this one right there. And the one that we're, right, is that 2, 0? Yep, this one's 2, 0. Now we have to try and figure out what is that one. It appears to be 1, 2, correct? Do we know for sure? And how would we check for sure? Okay, you could kind of use the chart, or do you agree that it's this line and that line that have come together to make that? So what I could do is come up here and either solve that system by elimination, substitution, or whatever, or if we think it's 1, 2, let's put 1, 2 in and see if it works. So if I put 1 in there and 2 in there, does it actually equal 4? And if I put 1 in there and 2 in there, does it actually equal 3? And it has to work in both of them, remember. That's what the whole system of equations was. So it is actually 1, 2. Very good. And again, if you really didn't know, if it was a really terrible spot, you would actually have to go and do elimination, matrices, substitution, whichever way you wanted to solve it, you would actually have to go and solve that system. Okay? All right. So now we got these points. But it appears as though there is something I haven't used yet. Determine the max min, and there's that weird looking f of whatever thing. I'm going to write it. It's right up here. I'm going to write it down here because that's where all my work is right now. That is called, that's the max min function, but that just looks weird. We're used to seeing f of x or stuff like that, g of x. This is f of x comma y. So what that's telling me is I want to find the max min. That's what it says up there. Whoa. What just happened? I want to find the max min if that was the max min function. Did I bother graphing that f of xy thing? Did I put that in my graph? Nope. Oh, all my lines are gone. That's weird. Freaky. Well, they're back. Okay. So now what we're going to do is we're going to find out of these are the only 4 of, how many were in here again? Infinite number of points, right? These are the only 4 that can be a max or a min. They're the only 4. A lot of these will still work, but these are the only ones that can be a max or a min. And what you do is you simply put them in here one by one. So let's try 0, 0. Let's put that one in first. So wherever I see an x, I'm going to put 0. Wherever I see a y, I'm going to put 0. So 0 plus 2 times 0 plus 1 is, notice again, I put 0 in for x, 0 in for y. is 1, right? And then we'll put in the next one. What do we got next? 0, 3. It really doesn't matter which ordered pairs you put in when. You have to put them all in anyway, so just put them in. So now wherever I see an x, I put 0. Wherever I see a y, I put 3. So 0, 2 times 3 plus 1. What do we got there? 7. Okay, so go ahead and just finish them up as I'm finishing them up. So f of 2, 0, huh? And we got to do f of 1, 2. All right, so 2 for x. Okay, so 2 plus 2 times 0 plus 1 is, what, 3? And now I put a 1 in for x and a 2 in for y. So 1 plus 2 times 2 plus 1 is 6. This is used a lot when you want to maximize or minimize something, and you don't want to use calculus to do it. All right? Calculus goes a lot faster. Could be profit, production, who knows. All right? And so we look back up here. They want me to find the max and the min, right? Okay. Max is the one that gives me the biggest value. And so the max is 7. Max equals 7 at where? 0, 3? Right, you see how I got that? 7, and it was at 0, 3, right? And the min equals 1, not too surprisingly, at, well, that's kind of a good one, at 0, 0. The one I made this morning was awesome. And that recording's lost, so there's no evidence of my awesome at symbol. And there we go. Yeah, this one's not very good. The one this morning was awesome. Okay, and so that's how you do it. Keep in mind, though, that if you have a system of inequalities, there may be no solution, just like before, or there may be an infinite number of solutions. Okay, because every single solution that I dotted in red quite a bit there is a solution to the inequalities, but maybe not a solution to the max-min function. Again, did I graph the max-min function? Ooh, and don't try to. It gets kind of complicated. Any questions? No? Well, let's hope it saves this time.